Hello, Course 2 Accelerated students. Welcome to Lesson 1-7, Words, Equations, Tables, and Graphs. In this lesson, we're going to learn and practice how to use multiple representations to represent relations. So, as the title says, words, equations, tables, and graphs, we're going to use multiple ways, or we're going to practice different ways to represent information. We're also going to translate among different verbal, tabular, graphical, and algebraic representations of relations. A real-world link has to do with fireworks. Physics can be used to calculate the path of fireworks. In general, for every 1-inch increase in shell diameter, a firework's height increases by about 100 feet. This relationship can be represented using an equation, a table, or a graph. So if we have a ratio here of for every 1 inch, it's going to increase by 100 feet. This could be used, you can see that we have a proportional relationship there, so we can use a graph, a table, to represent that relationship. So, representing relationships. You have already seen that a relation may be represented as a set of ordered pairs, right? You can also write a rule for the operation or operations performed on the domain value to get the range value, right? Domain is your input, and it'll go through a function to get your range value, so your y. A table may list the x coordinates, domain values, the rule, and the y coordinates, your range value. And that's what we're going to look at here in example 1. So you can see what they mean by that. You have your input right here, right? Then it goes through a function, and then it comes out as an output. So your domain, or your x-axis, horizontal axis, then it goes through a function to generate your y-axis, your output, your vertical coordinate, right? So let's see here. In a game of What's My Rule, Kina picked the card shown at the right. What's my rule? Double a number, then add 3. So multiply it by 2 and add 3. You see that? Double the number, whatever the number is, whatever you input is going to be represented by x. You see, these are all your x's. Then you multiply it by 2 and you add 3. So we have, right now x is 1, so we're going to replace x there for 1. Multiply times 2 plus add 3. X is 2 now. You see, x is 2. Multiply times 2, add 3. When x is 3, replace the variable. 3 times 2 plus 3. And then again, when x is 4, replace the variable with 4. It becomes 4 times 2 plus 3. And there you have your different outputs. You can see over here, it's always going up by 2, right? When it goes up by 1 in your input, it goes up by 2 in your output. In order to have this yourself, you have to follow this 3-step process. So first, create a table showing the x coordinates, the rule, and the y coordinates. Enter 4 different domain values. These 4 different domain values were just chosen. You can choose any domain at that point, because we could be talking essentially about anything, but what you want to do here is you want to show consistency to see how consistency may be on this side. The rule, double a number, then add 3, translates to doubling any number to x plus 3. Use the rule to complete the table. Step 3. The domain is 1, 2, 3, 4. 1, 2, 3, 4. And the range is 5, 7, 9, 11. 5, 7, 9, 11. Okay, let's try the got it section together. I will read through it and you will pause the video. And if you think you can do it on your own, go ahead, do it on your own, and then play the video to check your answer. Let's read it. Number 1. Jenna picked the game card shown. Make a table for 4 different domain values. Okay, so we're going to choose 4 different domain values and write an algebraic expression for the rule. Here's the rule. Then state the domain and range of the relation. So that's what we're going to do. Okay, we're going to go ahead and I'll make this little whiteboard here to work on. This would be the time for you to pause the video and try it on your own. Remember to go through steps 1, 2, and 3 as you saw in example 1. Pause now. Okay, so I've made my table here. I hope you're ready to check your own work. This will be my x, and here will be my y, and in the middle will be my function. My function reads triple the number and subtract 1. So it's going to be a number, the input will have to be triple, so 3 times x, and then subtract 1. Now I will choose 4 different values, 1, 2, 3, 4, and I will replace the x with that value, right? So I will be replacing this x that you see right there with the value of this x. So now I go ahead and I write it as 3 times 1 minus 1, 3 times 2 minus 1, 3 times 3 minus 1, 3 times 4 minus 1. And when I solve, I will follow order of operation. 3 times 1 is 3, minus 1 is 2. Number 2, 3 times 2 is 6, minus 1 is 5. Number 3, 3 times 3 is 9, minus 1 is 8. And finally, 3 times 4 is 12, minus 1 is 11. What am I seeing here? What kind of pattern? From 2 to 5, it went up by 3. From 5 to 8, it went up by 3. And from 8 to 11, it went up by 3. So they want us to, it says here, to make a table. Okay, we did that. For 4 different values. Okay, we did that. And then write an algebraic expression. We did that. You can see it here. 3x minus 1 is our algebraic expression. And then state the domain and the range. My domains are 1, 2, 3, 4, and my range are 2, 5, 8, 11. Now you realize these also become order pairs. If I wanted to graph this on a graph, it would be, my first coordinate would be 1, 2. Right? Because when I input 1, when x is 1, y will be 2. And then my next one would be 2, 5. Right? You see it right there. My next one, 3, 8. And my last one would be 4, 11. And I could use those order pairs to graph on a coordinate plane. So the main idea or the key point to this lesson is using multiple representations, multiple ways to show our data, our information. You can see here we have a table. You can see over here we have a graph. Let's read about it. Words, equations, tables, and graphs can be used to represent relations. Okay? When we talk about a relation is how does one number relate to the other number. Okay? So for example, kilometers per hour. Those two relate with distance over time, right? So that's rate. Now, an equation is a mathematical sentence stating that two quantities are equal, hence the word equation. They're equal. Relations are often written as equations with two variables, two numbers that can change. One to represent the domain values and one to represent the range value. Okay, so let's look here. Here's the concept summary. We have two different representation. Distance is equal to 60 miles per hour times the number of hours. So 60 miles per hour is our relationship. 1 hour would be 60. You would travel 60 miles if you traveled for 1 hour. If you travel for 2 hours, you would go as far as 120 miles. If you travel for 3 hours. Now that's assuming that you maintain the same speed the entire time. And there it is. Time, 1 hour, 60 miles. 2 hours, this value will double. 3 hours, it would double. 4 hours. Sorry, you would add 60 for each hour. So what would be our equation? Well, an equation needs to have an equal sign, right? And we need to say that our y is made up of what? Our y, our output, is made up of a rule. And what is that rule? Well, it's going to be made up of x when we multiply x times something, and that would be times 60. Right? That's our rule. That's our function. So every hour times 60 will give us our y. Let's see. 1 times 60, 60. 2 times 60, 120. 3 times 60, 180. 4 times 60, 240. See? There's our x times 60, and we generate our output. This right here is our equation, is y equals mx, where m is our rate of change. See, our rate of change is by 60 each time. M is our slope. Here's our slope. Let's check it on this side. So again, we took our x value here, and our y value, and our x became our domain, which is our horizontal line, right? Our x is our horizontal line, and our y is our vertical line, right? Our range, how much it increases by. 1 hour, 60. You can see it went right in between the 40 and the 80. 60 right in there. 2 hours, 120. 3 hours, what do we have for 3 hours over here? 180. 4 hours, 240. It keeps going up by 60 each time, and you can see that it is a linear equation because we can make a straight line, and it goes through our point of origin, so it also makes it proportional. Now, simply by looking at this, how can we identify our slope? Remember that slope is represented by m, and m is our rise over run. That's our slope. Well, let's see. Let's replace the y and let's replace the x with the numbers we're being given. If I want to replace it the first time, I would put 60, you see 60 for our y, and 1 for our x. So m is equal to 60 over 1. Or we often write it like this. This would be the same as saying 60 over 1 hour. 60 miles per hour. There's our rate, 60 miles per hour. Okay, that's our slope. Example 2. Now, let's take a look at some data they've given us on a table and on a graph. Just for future reference, anytime you're looking at a graph so that you don't get misled or confused, always look at the title first. What are we looking at? What is this information? GPS messages. So with that being said, anytime you ever make a graph, make sure you include your title because that's what people look at first. So we're looking at GPS messages. And then next you should look at your domains and your range. Okay, so your axis. Look at the x-axis. So what is it that we're doing? We're looking at times per minute, and we're looking at messages. So we have 50 minutes, 100 minutes, 150 minutes. Okay, so this looks like it's about 120 minutes in here, and 10 messages. Okay, so in about 2 hours, we had 10 messages. So keep that in mind. Now we've analyzed the graph. I love graphs. Okay, the navigation message from a satellite to a GPS, a global positioning system, in an airplane is sent once every 12 minutes. Write an equation to find, once every 12 minutes, got it. Write an equation to find the number of messages sent in any number of minutes. So let t represent the time and n represent the number of messages. Okay, so let's keep that in mind, that t will be time and n is number of messages. Right? Makes sense. The equation is the number of messages is equal to the time divided by 12. Why divided by 12? Well, they just told us that it's being measured every 12 hours. Okay, it's being every 12 hours. So let's divide the number of messages by every 12 hours so that we can see. We'll divide our time for every 12 minutes so that we can see the number of messages. So let's see here. We have time, 120 minutes, 2 hours, right? 180 minutes, 3 hours. Every 60 minutes, it's an hour, right? 4 hours, 5 hours. Divided by 12 is going to give us the number of messages. 10 messages, 15 messages, 20 messages, 25 messages. And then we can graph those. At 120 minutes, 10 messages. Okay, 180 minutes, 50 messages. 240 minutes, 20 messages. 300 minutes, so 5 hours, 25 messages. Okay, let's try that now. And this is our last example for this lesson. Okay. Number 2. Sound travels at about 1,088 feet per second at 32 Fahrenheit in dry air at sea level. Very specific, lots of variables. Temperature, moisture, altitude. Lots of variables, so it must travel at different speed depending on the temperature, depending on the humidity, and depending on the altitude from sea level. Interesting. Write an equation to find the distance traveled by sound for any number of seconds. Okay, so the sound travels 1,088 feet per second. Every single second, that's how fast it travels. Sound travels incredibly fast. So for any number of seconds, any number to me sounds like that's going to be our x. So x represents seconds. Okay? We'll let x represent seconds. That's our input. Our m, or rate, our slope, our rate, they told us is 1,088 feet per second. That's our rate per second. And our y will be a representation of those two, where m is multiplied times x, and that'll give us our output, our y. So y is equal to our distance, right? So they want us to write an equation to find the distance traveled by sound. So y will equal our total distance. I forgot to write the word total, so I'll put it in brackets. Total distance. Make sure you're making note of this so that it makes sense to you. So go ahead and draw a table, and we will have our x and then our function in the middle, and we already established that our function will be y equals mx, where m is the number of feet, so it's going to be 1,088 times x, and that's going to give us our y, right? Sorry for the mess here with the 8s. It's hard to write on an iPad. Okay, and let's go ahead and time it by seconds. So they say make a table to find the distance sound travels in 0, 1, 2, and 3 seconds. Then we will graph it. Okay, so I will replace my variable x, 1,088 times x, and I will do that for every one. So x at this point is 0, and then 1,088 times 1, 1,088 times 2, 1,088 times 3, and we have when x equals 0, y equals 0. That means they both will go through the origin. So it is a proportional relationship. 1,088 times 1 is 1,088. That'll be our first second. 1,088 times 2 is equal to 2,176. 1,088 times 3 equals 3,264. And there we go. So those are my order pairs. So remember, I have my range and my domain. So in my domain, which is my x values, I have 0, 1, 2, and 3. And for my range, which is my output, my y value, I also have 0. So when x is 0, my range will be 0. When x is 1, my output will be 1088. When x is 2, it'll be 2076. And when x is 3, my y will be 3264. Okay, and now we will make our table. Now it looks like I'm overlapping a little bit there. Let me just move it all down a little bit so you can see better. Okay, so for my table, you will see how I established my domain and my range. In my domain, I have time in seconds. 1, 2, 3, 4, 5 seconds. In my range, you'll see I have distance in feet. And I made 3 little ticks. Now I didn't write the numbers yet because I wanted to share with you that I'm going to use increments that fit best with these values. So I see that I have 1,000, then it jumps up to 2,000, then it jumps up to 3,000. So I believe an appropriate number to use, or increments to use, would be by 1,000. So I could put it as 1K. So that's 1,000. Then 2K, then 3K. I could write it like that, or I can write it as the actual number 1,000, 2,000, 3,000. Okay, just to show you that those are the increments. So it's increasing here by 1,000, while over here it's increasing by second. So my first order pair is 0, 0. Right, so my first one is right at the point of origin. My second one would be 1,000. 1 second is just over 1,000, and it's going to be around here 1,088, so about 1,100. So I'm just giving you guys an estimate. Now, if I had grid paper, it would be more exact. And then at 2 seconds, I have 2,200. Okay, so it goes up a little bit more at about there. Okay, and then at 3 seconds, I have 3,264. It'll be over the 3,000 mark, right about here or so. Okay, now again, this is not the most exact graph, but it shows you that it's proportionally increasing at a rate of 1,088 each time. And if I were to draw a line, it would be a nice straight line, which will help us predict more outcomes. If we continue to increase, for example, at 5, when I go up 5 and it meets the line, wherever the line meets up here, it's going to tell me that the next value. Okay, and that's it for today, everyone. Here is our guided practice for next class. You can see it right there. You can pause, take a look at it, make sure that you feel comfortable with the content. If you have any questions about the guided practice, you can always visit example 1 from the video or example 2 from the video. We will do this together in class. That's why it's a guided practice. And here's the independent as well. Just again giving you a quick preview so that you are comfortable with the content we will be looking at in class. See you then, everyone.